Thank you, everyone, for joining. We're going to get started. So it's a very exciting day here at Snowflake. Some of you may have noticed that we actually sent out a couple of press releases this morning. One of them was related to the fact that we have closed an additional round of funding to help us as we grow and as we continue to rapidly grow. And the other announcement was that we actually went out and officially announced that the product is generally available. So a lot of you I know have been using the product for some time, and we've actually been in effectively limited availability where we've had people using the product in production for some time. But we felt that today was a great point in time in which we felt extremely confident that with the help of your testing and your evaluation and your feedback, we've been able to check off all of the key boxes to be able to offer this product on the market to a broad variety of customers and a broad variety of use cases. So encourage you to take a look at the website. There's some new content there, new content describing how Snowflake works and new content about customers as well. And also, certainly take a look at all of the different things that are being written about Snowflake. There's been a lot of interest from just the general public about Snowflake and what we're doing. So with that, we wanted to thank you all for having been part of this journey that we've had. I know a number of you started talking to Snowflake very early in our product, and some others of you have actually just started working with Snowflake recently. But in part to thank you for just the feedback and the engagement that you've had with us, we wanted to give you kind of a sneak peek of a lot of the new functionality we've been developing over the last 6 to 9 months. So some of this will be new to most of you. Some of it might be things that a few of you have seen before. But there's been just a huge amount of innovation that's gone on over the last 6 to 9 months, and we wanted to give you all the first chance to see some of the details of that. So one thing I did want to do is I wanted to have Benoit, our CTO, and one of the co-founders who's been here since the very beginning. I wanted to have him say a few words. But before we do that, let's actually just cover a handful of logistics. So all of you who have logged in have figured out how to get the ReadyTalk system up and running. There is a chat window down at the lower left. That chat window can be used to send questions to us. We will take questions as we are able. If we have extra time at the end, we will certainly take time and answer questions at the end. But if we don't, we'll certainly make sure that we get back in touch with you to make sure that we do answer those questions. So I am joined today by Benoit as well as by Steve Herskovits, who is our Director of Sales Engineering. And as I mentioned, Benoit has been really kind of the heart and the soul of the company from the very beginning. So I wanted to give him a chance to just say a few words about kind of his experience here and his excitement about today and what it means.
Yeah, hi, thanks, John. So first I wanted to welcome everyone on the call. As you can imagine, as John was saying, today is a big day for us. Is our GA. So this is probably the most exciting day in our short history, and it's definitely one of the most exciting day of my life. We have been working for Snowflake with our vision of Snowflake back almost 3 years ago. And when we founded Snowflake, really what we wanted is we wanted to reinvent data warehousing for the cloud world. And that's what we meant is we wanted really to build something first as a service, and where extreme simplicity would be really the focus. So we wanted customer just to load their data, run their query, and that's it, and we will do everything else. The other aspect of Snowflake is we wanted to create a data warehousing for all data, and what we mean by all data is any shape. So we, as you guys know, we support both semi-structured data as well as structured data. And for us, semi-structured data is really, structured data is really a special case of semi-structured data. So we natively support semi-structured data, both to ingest, of course, but also to process and query. And we want to support that data at any volume. And our design goal was to support potentially petabytes of this semi-structured data at a very low cost. And finally, we wanted to build an architecture, a very different architecture from traditional databases, which are either shared nothing or shared disk architecture. So our architecture is different, and we call it the multi-cluster, shared data architecture. And that's the goal of that architecture, is really to leverage the cloud and the instance provisioning that the cloud offers, such that we can make this architecture super elastic and across multiple dimensions. Like you can grow data, you can grow the size of the data, but of course also the number of users. But of course to implement that dream, we had to build everything from scratch, and we couldn't leverage any existing software because of the special architecture that I mentioned. And we really, when we designed Snowflake, we really thought that if we put the right foundation and we build a very solid foundation, then we could, build that system in 3 years. So that was our goal when we started. And actually, we did much better than that. We built Snowflake in a little bit less than 3 years, so not that much better. But we built, something that was much more solid and much more, robust that we had envisioned for our, version 1. That's how version 1 would be. And in particular, Steve and John will walk through all the features that we have added to make, Snowflake really the most amazing service in probably the world. And for that, I would like, this is a truly amazing feat, and I'd like to thank, Snowflake, the entire Snowflake team, and that would not have been possible without them. So we have an amazing team, and I would like to take advantage of this GA date to thank them. So back to the webinar now. As John was saying, many of you guys looked at us way back then when we really had only the foundations of our system and mostly only the architecture, this multi-cluster architecture. And since then, we have added a lot of features. Actually, most of these features are probably not very visible to you guys, and we are, either demonstrating them or explaining them to you in the next, few demonstrations. So John, back to you, and Steve, back to you.
Okay.
And thank you guys, and thanks everyone on the call again.
Okay, great. Thank you, Benoit. So, before we start diving into specific features and the demos of some of those features, I just wanted to kind of set the stage by just recapping, what we have had as our product vision. And one of the interesting things is when I first joined Snowflake and first started talking to Benoit is how consistent that vision's been. And it really comes down to, these 3 things: making it easy for people to get all of their data together that they want to analyze, making it possible to have data warehousing be available as a service that people can really focus on using their data as opposed to focusing on infrastructure and tuning and tweaking and all of that. And then supporting diverse data and diverse analytics, everything from ad hoc to exploratory and reporting and all of the different ways that people can use their data. The way that we approached that, as Benoit mentioned, was we had to start by building a database engine. And as all of you know, that was something that we built ourselves. So we built that completely from the ground up. It wasn't based on something like Postgres or Hadoop or anything else. And then on top of that, we did a lot of work, especially in the last 6 to 9 months, in really kind of building that service aspect of this. And so that includes everything from making sure that availability is just a built-in capability. Data protection is just built in. Security enforcement is just built in, as well as a lot of the things that we talked to you all about earlier about not having to manage and tune and optimize the system. And then, that actually brought us to the point where we have a huge amount of opportunity to innovate. One of the things that Benoit likes to say is that we're really just at the start of all the innovation that's possible because of the foundations that we've laid. So with that, I wanted to transition to walking through a number of the different things that have been changed, improved, or added since some of you may have first started looking at Snowflake. And one of them that's very front and center, because it's one of the first things that you'd see if you are logging in as a Snowflake user, is that we've actually done a lot of work on iterating and making the user interface through the web user interface easier and easier to use. And so this is something that when we get into the demo, we'll certainly see in much more detail. But fundamentally, it's been about making the layout cleaner, making it easier to access the key information that you need, and having that all available at your fingertips. Because certainly, when we first started, it was actually a little bit unusual to build our own UI with the SQL client. Most UIs for databases are really management UIs. But we started to see that as people were trying out the product, the web UI that we built was an increasingly important part of how they actually tried out the product. And even some of our production customers are still using the UI. So that's been an important area of focus for us. To build out that core database engine, we wanted to make sure that we could be that we could support a pretty broad variety of SQL. So both the SQL as defined by the standards out there from ANSI, but also just the different variations of SQL that make sense that are not proprietary that are offered by varying vendors. So we spent a lot of time getting that core SQL in place, and when we first came out of Stealth back in October, we actually had a lot of that there, and we've since added to that, to the point where now I haven't seen a lot of questions come in asking for features in core SQL that we don't have. And so some of the things that we've added, we have basically full support for DML operations, everything from insert to merge to update to delete. We've also added multi-statement transactions to the list of things that we support because that is something that was very important to provide as well. We've also, for quite a while now, had analytic SQL capabilities. So windowing functions, ranking functions, the core set of SQL that people use typically in analytics. And we've even extended that by putting SQL UDFs into the product. So now there's that additional degree of customizability and ease of use that comes from being able to define SQL UDF functions and reuse those and compose your analytics out of those. So this is just a core set of some of the key things that we've done that have really been around that core SQL database engine. But there's also some interesting things that we've done that take SQL into places that typically it hadn't gone before. And one of them that we think is pretty interesting and extremely valuable is what we call time travel. So time travel is based on the fact that the way that we have implemented the storage persistence in Snowflake is that we actually never overwrite data that's in the system. Anytime that new data is written, we actually write that in a separate object, and we store that in Amazon's S3. And so we actually have the full history of all changes at all points in time. Now, there is a retention window because certainly, keeping changes for 10 years would mean an awful lot of disk storage would be used. But during that retention period, which is determined by the length of a customer contract, we actually have the ability to recover that past data instantly. Because it's just a metadata operation, we don't need to restore from backups. We don't need to rebuild the way that the data is laid out and stored. So that covers a pretty broad spectrum of things, everything from being able to undo accidental things like a drop of a table or drop of a database. Now that's just a simple SQL command, and so we've basically made that available through SQL. But also going beyond that to be able to do queries that go and grab previous versions of the data. So because we have all versions of the data and we know when changes are made to the data, you can write a query that says, give me the version of this table as it existed 5 minutes ago or 2 days ago. And you can instantly have access to that during that retention period. So there's a lot of different directions that this can be taken. One is obviously for data protection. So I can undrop something that was accidentally dropped. If I had an ETL job that corrupted something, I can almost instantly just clone the previous version and then have that old data back and available again. Or if I simply want to see what's changed, I now have the ability to do that using this time travel feature. So that's a segue into one of the first things that Steve is going to demo. And so I'm going to turn it over to him, and he's going to talk about a handful of different features, some of which I mentioned just now, and some of which are ones that I did not mention. So Steve.
Thank you, John. Desktop. Okay, so what I'm showing now is the Snowflake web UI, and this may be familiar to some of you who have seen recent demos. Those of you who may have seen a demo some time ago, you'll notice that the layout is different. We used to have the 3 panes stacked across the top, but now we have the SQL pane on the left so that we have more room to be able to see more of your SQL when you are editing it. Top right, we have the statement pane, which shows statements that you have been executing or are executing now, and you get throughput information about those statements. And then down below in the lower right-hand corner, we have the results pane, which shows us the result set for any statement that we have selected. So again, those of you who have seen this demo know that the story we tell is about Peter, the ETL guy, and he does a bunch of ETL. He loads roughly 1 billion rows in about 2 minutes in this ETL, and that's accomplished with this set of copy statements. Now, one of the new features that we're talking about that we've just added is to be able to see the load history for any given table. So the show load history command, show load history in line item, is showing us the load history for that one table, the line item table, and it shows us all of the files that were loaded from S3, what their MD5 checksum is, what kind of errors we found, etc. An example here of the time travel, simple example, shows us looking at this line item table before and after we loaded the 600 million rows that are in it. So this is doing 2 different selects. One of them is asking for the current state of the line item table. The first one here is looking at the state of the line item table 2 minutes prior. This offset 60 times 2 is the number of seconds prior to the current time that it's showing us. And if we look at the results, we see that before we ran Peter's ETL job, we had roughly 5,000 rows of seed data. And after that, we had the 600 million rows that we've just added.
So Steve, you showed an example there where you're comparing the states of data at different points in time. What other options do you have to look at what previous data was?
Yeah, so you can, you can specify not just an offset, but you can specify timestamps. You can specify a query ID that you want to see the state of the table either before or after. And I actually have a couple of other examples of that I'll show coming up. Okay, another feature that is probably new for many of the people who've seen our demos is parallel unload. So same copy statements that we use to load data from staging areas here can be used when flipped around as unloads. So in these cases, we're copying into a table from a staging area. If I show you this line here, we're copying into a staging area from a table. So this is essentially unload. It uses the same file format object in this case that we used to load. But in these cases, we are taking data that had been loaded from an external stage, and we are now unloading it into a Snowflake internal stage, which is represented by @tilde. So this tilde means it's the internal stage associated with my user. And so here we see that we unloaded these 1,467 files. These are gzipped files in CSV format according to the rules in that file format object. And so we do parallel unloads.
So Steve, I see that you're getting multiple files as your output there. Do you have other options if I want to, for example, get it all in one file?
Yes, there is an option to get it all in one file. The only limit there is that you're not going to get the full advantage of the parallelism because everything has to be brought together. And there are some S3 limits onto the size, the maximum size of a single file. But for modest tables, you can ask for a single file output.
I could basically use a file format to define any output. It doesn't have to be the same as what I loaded, right?
Yes, that's right. I chose to use the same file format object in this case for simplicity, but you could take in a comma-separated file and you could output it as pipe delimited. And you're not restricted to unloading into the Snowflake internal stage. You can unload to your external S3 buckets as well. All right, so the continuation of Peter's ETL story is that he's happy with these billion rows he's just loaded, and he wants to take advantage of our clone feature to be able to hand off a copy of this new database, of the sales database, to his test and dev team, so he can give them a safe copy. So if we switch to the Databases tab, we see the three databases that Peter has access to. And the sales database is the one he's just loaded with those billion rows. See what the tables are. In particular, we see this big line item, 600 million row line item table that we were looking at. So if we come back to sales, to the database tab, and we choose to clone the sales database. So we're going to call this sales good, because this is the good data that Peter wants to hand off to his test and dev. Here we're doing a zero copy clone of the sales database, and we've made this clone purely at the metadata level. We have not copied any of the underlying data. If we click into sales good, we see it has the same tables. Right? Now I want to demonstrate a couple of the other features. So we can now do any kind of damage we might want. So let's say the test and dev team goes a little crazy and they've got a logic error and they accidentally drop your line item table. We can drop this table, 600 million row table. So the first thing to notice, if we switch back to sales, that the original sales database that we cloned still has its line item table. When we come back into sales good, right, it is missing its line item table. But John was mentioning that we also have an undrop command. So let's just demonstrate that. This by hand. We're going to make the sales good, the clone database, we're going to make that current, and we're going to undrop table line item. All right, so notice the result of this is table line item is successfully restored. If we switch back to the tables tab, sales good, we now see it's refreshed, the line item table exists again. We've got our 600 million rows back. So you can use clone and undrop to protect yourself from errors and then to recover from human errors.
And anything can be undropped, right? Not only a table, but a schema, a database too.
Yes, yes. Thanks, Benoit. Okay, back to you, John.
Okay. Another thing that we've made a lot of engineering, or that we've done a lot of engineering work on, has just been expanding the functions that we have available in our libraries. And we actually have a pretty broad set of functions available in these libraries. You know, we've compared against other commercial databases, and you know, we have a pretty broad set that matches those. Now, these functions are not machine learning functions primarily, but they are, you know, definitely functions that are very valuable in analysis. So everything from different types of aggregation functions to functions for manipulating dates and times to additional functions for strings, and some other interesting things that range from the hyperlog log, which I know a number of you have actually been very interested in, to some additional functions for JSON parsing, and also even some context functions. So these were, you know, additions that we've made in the last several months. We certainly started with a pretty broad library of mathematical functions, you know, string functions, regular expression functions, and aggregation functions already. But we've continued to add to that. And certainly, you know, if there are things that, you know, you think would be very valuable, by all means, let us know, because we're very responsive to that feedback, and we want to make sure that we're providing a pretty rich library for what people want to do. So with that, I actually wanted to turn it back to Steve, who I believe has an example of hyperlog log and using that in Snowflake.
You? I got to grab the... Okay, so what I've loaded into my SQL worksheet area is a new script that demonstrates hyperlog log. It starts with an example which does a count distinct, and we're using that 600 million row line items table to do this. So it's counting the distinct orders in that table. We have an example here of hyperlog log, which is going to estimate the number of distinct orders. And then we've got a query which will compare those two estimates. Now, I ran that while John was speaking just now. And what we can see is that the count distinct ran at about 4.8 seconds. And again, this is a 600 million row table, so it's not gigantic big data. It's sort of small big data. And we're seeing the hyperlog example with the estimates runs in about 1.6 seconds, so roughly 3 times as fast. And obviously, the bigger your data, the better advantage you're going to get from running the hyperlog log estimation. This next query shows a comparison between them and the amount of error that the estimation is getting versus the actual counts. So you're getting very good approximations for your HLL. Now, this example also includes a couple of extra time travel examples. And what I wanted to do is just quickly go through those. In particular, we're going to switch to, I want to show you is, I got an error. Well, this proves my demo is real, but it's live. Not available. I think I had a wrong timestamp, so maybe what I'll do is just show you the example syntax here. The timestamp that I got the error from was I was reaching back to a particular timestamp in order to show the number of rows in the line item table at that time. And then we also are able to, we can ask for any timestamp, and here I've given an example of asking for one in the future. And I'll just run this one manually. And we get the error message, the future data is not available. So basically, these two errors show you that if you ask for a timestamp prior to the existence of the table, you'll be told that the data does not exist, is not available yet. And similarly, if you ask for something out of range too far in the future.
And there's a feature request for that future data thing, right?
Yes, everybody wants the future data.
Okay, we'll keep working on that one.
All right. Now, as part of this, I want to demonstrate one other feature that John had to mention, which is that these result sets are persistent. So we were showing you here, for example, let's find this is the comparison between the actual orders and the estimated orders. So this result set is persistent. If I log out as Peter from this current session, so I'm going to log out. Now if I log back in, all right, when we log back in and go back to that worksheet, we see that we've lost the, whatever was in that session's SQL panel and the current statement pane is also empty. But the History tab lets us look at all the things that Peter has been running. And in particular, we're able to look at any of these queries, and we can see the results that occurred at the time I ran that. So this is important because it means that you can be running your queries from command line, you can be running them from BI tools, and you can come into the Snowflake web UI and you can see the result sets from the statements that you ran in other client tools or that you ran in the web UI at a previous time.
So Steve, if I had started something from a BI tool and I wanted to see the results sometime later, I could actually log in to the Snowflake UI and I would see the result?
Yes, in fact, during our normal live demos when we show integration with Looker and Tableau, we show you that you can see the queries and the result sets that those BI tools issued and were returned.
Okay. Or I could even go back and I could see the results of something a script ran then, I guess, right?
Yes, exactly. And it doesn't have to be a script run from the web UI. It can be run from our command line client, SF-SQL, or it can be run from your own custom client using JDBC and ODBC. Okay, back to you.
Okay. So another thing that we have spent a huge amount of time on, and this is one of those that's pretty far under the covers, so it's extraordinarily important and valuable, but one of the sort of things you may not even have known happened, and that is we did a huge amount of work building out a fully resilient system. So when we built version kind of 0.1 of Snowflake, it already was using Amazon's S3, and Amazon S3, as I'm sure most of you are aware, is extraordinarily durable. Amazon replicates data across multiple disk devices, multiple data centers, and does that all synchronously and transparently. So we already had the actual persistent storage of data highly replicated by Snowflake. But what we did in the last 6 to 9 months was we also made sure that we could take advantage of redundancy and fault tolerance across a lot of different types of failures in the other layers of our architecture. I'm sure you remember the virtual warehouses and the cloud services are the other 2 layers of our architecture. Virtual warehouses can now be provisioned by Snowflake in any of the 3 availability zones that typically exist in a region. And Snowflake takes care of that automatically. So if we see that a given availability zone no longer has capacity, we will automatically provision virtual warehouses in a different availability zone. Now, any one virtual warehouse will always be provisioned within a single availability zone because for performance reasons, you want the different nodes in that cluster together. But if there were to be some catastrophic failure, we can actually go ahead and provision a new virtual warehouse. You can provision a new virtual warehouse in a different availability zone. And because the data is stored in S3, you actually then can immediately start querying that data from that new virtual warehouse. So a typical DR scenario would be that you would actually have to take and make sure that the data was replicated, and then you would have to spin up an entirely new cluster. In Snowflake, it's almost a trivial operation to do that. One other layer that is also pretty critically important is that cloud services layer. And so this is the layer that handles everything from being the endpoint that your client tools are talking to managing how queries are parsed and distributed to the virtual warehouses, to managing the metadata about where all the data is stored in Snowflake and all of those aspects. So that is something we also spent a huge amount of engineering work on, making sure that that was scale out, resilient, and redundant. So now our metadata storage layer is resilient and redundant both within an availability zone and across multiple availability zones. And the cloud services are also redundant and resilient across multiple availability zones. So fundamentally, what this is a system that can tolerate a huge range of failures transparently. Everything from the case where a single server or single component were to fail, to the case where an entire availability zone from Amazon would be inaccessible, maybe because of capacity issues or things like that. And one other benefit that those of you who are customers of Snowflake have seen is that this allows us to do online upgrades. And so now we actually frequently will push very small changes to code on a regular basis because we have the ability to do that completely transparently without disrupting any queries. And that actually makes for a much more stable system because large upgrades are always the bane of any complex systems availability. And so it's actually allowed us to dramatically improve uptime and make updates completely transparent. And we have the ability to do that, basically, completely when we need to do that for software updates. And if there were to be a problem, we actually have the ability to instantly roll back to previous versions as well. So now this is something that's a little bit tricky to demo. So I went ahead and actually recorded a demo of it because we wanted to make sure that we actually had all of this put together, and we actually had to create a special environment to do this demo. So we wanted to be able to actually introduce a failure into the system. If we all sat here and waited for a failure to happen in Amazon, this could be a 1-hour webinar, it could be a 6-week webinar. And I don't think we want to do a 6-week webinar, so we decided to record this and cut a little bit of time out just to kind of show you how this would work. So what I'm going to do is start with a scenario where I have here, obviously the Snowflake user interface on the right, and I have 2 workloads running on that are being driven continuously by some scripts. So one workload is basically taking a query set and running 10 streams of that in parallel and just iterating through that on an ongoing basis. And so that top chart you see there is showing you the throughput, basically queries per second, that is being generated by that as measured by JMeter. The bottom is another job that's running at the same time, which is basically doing an incremental insert. So it's taking the current value, adding one to it, adding a row into a table with that new value, adding one, adding the next row in. And the reason that we're doing that is to be able to actually detect if there's any places where there would be disruption. So in this case, we're actually computing the running total on the client side, the script side, and we're also computing the running total on the database side. So after every database query, we actually go ahead and compute the running total as a database. After every insert, we compute the running total as a database query and compare those 2 results. So you may not be able to see the details of the text, but basically, if there were to be a case where a query was issued on the client side and never finished executing on the server side, on the database side, there would be a gap in that sequence. And so that last column there indicates success or failure. Basically, does the client side computed value match the side that is computed on the database? So what we're doing here is you can see all those jobs running in the Snowflake user interface, and they're all, as you can see, they're all executing on that virtual warehouse that we have defined. So now we're going to go ahead and we're actually going to introduce a failure. And the way that we do that is we actually behind the scenes go and actually kill off a virtual warehouse. So that's something that we couldn't do except for this special environment that we set up. So that's why I couldn't do this except in a special environment. But we went ahead now and in the background we went ahead and killed off 4 of the nodes actually of that virtual warehouse. So effectively half the virtual warehouse, because this is a medium warehouse. So basically half the nodes of that virtual warehouse they disappeared. And in a typical database, that would have meant that data would probably have been lost. Most databases keep 3 copies of data internally. In the Snowflake case, because we keep a copy of data on Amazon's S3, that's actually, there's no data loss, even if we were to lose all the nodes. Now, as you saw, several of that queries now went into that state that said repairing warehouse. And you can see here that, that warehouse is actually in the state repairing. So that status column on the left, it's a little bit blurry, but it does say that the warehouse is being repaired. And what's happening here is Snowflake has now detected that there are nodes that are no longer responding, and it's reprovisioning new nodes, adding them back into the warehouse. So now actually those new nodes have been added back in, and so now the warehouse is back at almost full strength. Basically in this screen it actually would say the warehouse is at 75% strength, meaning I've replaced 75% of I've replaced enough nodes that 75% of them are available. And so transparently the queries have continued running, the warehouse has been recovered, and so it's reprovisioning all those nodes, getting them back into the system, and nothing's been dropped. So it's a little blurry again, but if you were to be able to see the details of the script that's running on the left, there is one place where there was a hiccup where it took a lot longer for one query to complete, but throughout not a single query was dropped, even though in this case the actual time to first detect the warehouse failure, it was about 30 seconds, because we have a number of steps we go through just to make sure that there is really truly a warehouse failure, and that took about 30 seconds in this case. And then reprovisioning the nodes, it'll depending on whether or not we have spare nodes in our pool that we maintain. If we have spare nodes, we will recover those nodes, almost instantly. But if we need to go and request new nodes from Amazon, then certainly that can take a few minutes. And so in this case, like requesting those new nodes, adding them back into the cluster, it took about 40 to 50 seconds in this case, because we did have some available in our pool. So that's a quick demo of just the fact that even if we were to lose most of the nodes or even all the nodes in a virtual warehouse, queries will complete successfului if we lose just say one node out of a large warehouse, we'll actually just continue executing the query on the remaining nodes, and there's no need for data repartitioning. All the data is still available. But if we were to lose a significant share of the nodes and we no longer have quorum in the virtual warehouse, we will actually reissue that query once we have recovered enough nodes to have a quorum in that virtual warehouse. And that all happens transparently. From the client side, a query would have taken longer, but it would have executed successfully, and we wouldn't have received the failing error message in that case. And it's not just the case where a complete failure of a node is the only thing we detect. We actually also detect impaired nodes. So if a node were to be severely impaired, maybe it responds to pings, but it actually isn't really processing any jobs. We actually automatically will detect that, kick it out of the cluster, and replace that with a healthy node. So this is just one example of transparent availability and failover that we spent a lot of time building into Snowflake. So with that, there's a couple more things I wanted to talk about in a little bit different subject. And one of them is one that I know a lot of you have been using already, those of you who are Snowflake customers, and that is around semi-structured data. So it's really been one of the key features that we've added that has really been of interest to people, is the ability to query semi-structured data transparently and optimize it transparently. So we already had that back in October when we first came out of Stealth, but we've done a lot of work to really optimize that since then. And part of that has been adding a lot of optimizations that really do look at the semi-structured data, for example, JSON, as we load it, and really do identify what data attributes are repeated, and then store those in the same way that a columnar database would store columns in separate objects so that we can very quickly retrieve them. And because we've built up the metadata, we know, for example, that if we found an ID column, we broke that out, and we have metadata about where that's stored. We have the ability to use that then when it comes to query time. And so that query optimization side of it was another part of what we've added in over the last several months, so that you can get significantly better JSON and Avro query performance than you would be able to in any traditional option, whether that option would be running a processing job in something like Hadoop, or using a database that had some extension to support these blobs or other types of black box objects that are often the ways that people load semi-structured data in those databases. And so that's a pretty differentiated capability that doesn't exist in a lot of the other things that are out there. So with that, I wanted to turn it back to Steve, who's going to demo a couple little things related to some of the things I've talked about, as well as some other things as well.
Okay, thank you again, John. All right, so I've loaded a new script which demonstrates some semi-structured support as well as our multi-table insert statement. And then I ran it while John was speaking. So just to kind of walk you through it very quickly, it starts with creating a table which has a variant column. So Snowflake supports all the standard ANSI column types, but we also have a variant column, which is what holds our semi-structured data. And this hit data column then is what is going to be used in a number of the other queries below. There are some auxiliary tables here that aren't really of importance right now for our discussion. What I want to bring you down to is where we are loading two different tables with semi-structured data, actually three different tables. One is the customer interest table. We are doing a load from that site data table where we are using our flatten function, and let me expand this so you can see the entire line. And this flatten function basically is looking at an array that's inside the site data table hit data column. It's using a JSON path to reference a particular object, which is an array inside that JSON object. And that array then is being flattened. The elements inside the array are being treated as a virtual table and then joined as part of this query. So we're using this then to insert elements from each of those into the customer interest table. Similarly, we are using the site data without any flatten, without any flatten join going on. We're just using it directly with JSON expressions in the select list. And this is within our multi-table insert. So let's first focus on the select that's here. So we're reading data from the site data table, the hit data column, and then we are referencing in to JSON elements inside the JSON object, casting those as needed and assigning them regular SQL aliases. The insert, the multi-table insert then, is able to use these in a variety of ways. So first, just to describe what the insert does. An insert, a multi-table insert, will, based on conditions described in a when clause, do inserts into one or more various tables. And you can have multiple intos for each when. You can have multiple when clauses. And what you're seeing here is a couple of examples of this, where in particular we're using here the device type is a field that's been extracted from the JSON. So that's being used as part of this condition. If it's not null, then we insert a row into the user agent data, pulling other aliased elements from that JSON object into that insert. Similarly, right, when the product line doesn't contain the phrase none, again, product line is one of these JSON extracted elements. So the idea here is that you can pull data in from your semi-structured data sources and using the MPP power of Snowflake, basically blast out what column data you want to have extracted and normalized into your target tables. You can also, and we recommend this, you can also preserve that JSON variant into a variant in one of those target tables so that you always have access to it. If at some point in your analysis you decide that there was an element in the JSON that you previously didn't think you needed to extract and now you decide you do want to. Let's take a quick look at the way that works. We look at, so this first insert, this was inserting into customer interests, right? And this loaded 1.7 million rows of data pulled, from this JSON object. The next is the multi-table insert. And the report you get back from a multi-table insert is how many rows were written or inserted into each of the three target tables. So here we see that we've written anywhere from 3.5 million to a little over 5 million into each of those. Now just for fun, I wanted to demonstrate a feature that was not mentioned by John, and that is the ability to do large result set handling and infinite scrolling in our UI. So I've got here a statement that selects from these customer interests. It selects just the first 500,000 of them. Now, typically when people use a limit clause, they use numbers like 5 or 10 or maybe 20. But I'm limiting, I just want to see the first 500,000. So if we look at that here, right, we see that we got 500,000 rows. The first thing to notice is that it took 1.6 seconds, right, to produce this 500,000 row result set. But also I want to show that we can scroll through these. If I grab the thumb right here, I can scroll all the way to the bottom. And you can see that those last few rows in this 500,000 row. I can also scroll anywhere into the middle of this large result set. We've got large result set handling and infinite scrolling within our UI. Okay, I'm going to turn it back to John.
Okay. So a couple more things I wanted to cover that are pretty important to a lot of you, I know. And one area is certainly security. So that is another area that we spent a fair amount of engineering time adding in capabilities over the last several months. And I know a number of you probably have already seen the fact that we have rolled out multi-factor authentication. So that's now something where we actually have an embedded MFA server, and all you need to do is let us know that you want to turn that on. We do recommend that for all administrative accounts, and certainly you may want to do it for additional users that have access to things that you want to make sure that you're protecting. We also have deployed encryption for all data at rest. So basically, from the moment data leaves, a client, it's required to be over a secure connection to Snowflake. We only support SSL. We don't support unencrypted connections. And then everywhere that we store data inside of Snowflake, we actually encrypt it. We did a lot of testing, and we found that the overhead of encrypting data was so small that it just made sense to just have it always on. So all of that is done with keys managed on our side, and we do manage a hierarchy of keys. There's actually a white paper on our website if you want to get a little bit more detail about encryption in Snowflake and how we implemented that. But that's all available now by default, with inside of Snowflake, without you having to turn it on or to worry about managing that. And the other thing that we implemented is pretty granular role-based access control. So this is something that those of you who worked with enterprise-class databases in the past will definitely be familiar with. The notion is that you have roles, and roles are granted or revoked privileges on objects, and then roles are assigned to actual users. So in this case, I have a role A, which has a couple of different privileges, or which has actually one privilege on that object there. and that role is assigned to 2 of those users. And users can actually be assigned multiple roles and can assume different roles. So this gives you not only control over what can be accessed. So for example, can this user or this role access this table? That's one aspect of what you can control. But you can also control what someone can do on that object. So that applies even to a virtual warehouse, because a virtual warehouse is an object in Snowflake. So I could actually use role-based access control to determine which users can, for example, start a virtual warehouse or create a virtual warehouse. I can use that to control which users can access certain data. I can use it even to control things like which users have access to certain stages. So you have a lot of flexibility here to really define the access control policies that you need for your own requirements. So I wanted to turn it back over to Steve, who's going to give just a short little demo of that.
Okay, thanks, John. So I wanted to point out a few things about our UI. So number one, when you are logged in the upper right-hand corner, it identifies not just your login ID, but the role that you currently have. And so here we're logged in as Peter, and we can see that he has the DBA role. I also have switched to the Warehouses tab, and we can see the reporting warehouse that Peter has spun up to do his work and that we've been using for the demo. I have also, however, logged in as Marie, who is a BI analyst in the United States. And Marie does not have permission to use Peter's report warehouse, but she did have permission to spin up her own campaign warehouse. So you'll notice that, as John mentions, we can control, using RBAC, who has the ability to use or see each other's warehouses. Now, just to show that this works live, Marie decides that Peter, the DBA, should be able to use her campaign warehouse if he wants to. So if I switch over to the worksheet, I can have Marie grant usage on her warehouse the role DBA. So she doesn't grant permission to Peter as a user. She grants permission to the role that Peter has assigned to him. So when we grant this usage and we switch back to Peter, do a refresh, we see now that Peter can see both of these warehouses. So he now has the ability to use either warehouse for his ETL work. Similarly, just like to point out that for more conventional objects, right, so we've got Peter can see the 3 original databases that we have, plus the clone that we created earlier in the demo. If I log in as, imagine that you've got a multinational company and that you've got people working in other countries. So if I log in as Chloe, who works in Australia, what we'll see is that Chloe does not have permission. She can't see either of those warehouses that we know exist. And when she looks at the databases, she sees the 3 original United States databases, but she does not see the clone that was created because she was not granted permission to that. But she herself has now permission to see the Australian sales data, which none of the other users have. And we're able to control this at this fine level with role-based access control. One last thing to show you is that if I log in as the admin, I will have access to see all of those objects. But moreover, I can show you that we've implemented multi-factor authentication. The admin user is using Duo Push, and you can't see this, but my cell phone is buzzing, and I'm getting a request to confirm this login is valid. And when I press the buttons on my phone, I'm logged in. And when the admin logs in and switches over to the database tab, now we can see all of the national databases plus the U.S. data.
Now, Steve, could I actually use multi-factor authentication if I'm using a client?
Yes, you can. You can control, basically you can assign any user ID can be assigned a smartphone number, and when you log in through a command line client, you can either specify the code that came from your MFA device, or you can have it buzz you in the same way. So as part of what I do for our demo setups, I run a script which uses this admin user that I've just shown, and I'm running it from the command line client, and it buzzes my phone in the same way that it did just now. Okay, so I think we're good. Back to
okay. So just a couple last things. One is that certainly with security comes validation that we are doing the right things with security, and so we have actually gone out and worked with third-party auditors, both on the attestation. So basically they review and make sure that we have all the right processes and controls in place. And we are planning on completing the audit. That requires a window of time over which the auditors certify that we have actually been implementing all those controls. Just a couple last things before we wrap up. One is that we continue to make additional engineering investments in deeper and deeper integrations with the ecosystem. So we already have ODBC and JDBC, and we've had that for some time, and that allows us to work with the vast majority of tools out there that understand databases. But there's even opportunities for deeper integration with some partners in the ecosystem. So one thing that we announced recently at Informatica World was that we actually have an Informatica Cloud Connector, and that is effectively a native connector for Informatica that allows us to translate Informatica's operations, which are by default individual row inserts, to bulk operations that Snowflake is meant for and is more efficient at. So that connector allows us to get optimized performance, loading, and pushing data into Snowflake from Informatica without the user of Informatica needing to change their processes or needing to understand the details of how that works. So that's certainly a very valuable integration on the ETL side. On the BI side, we've actually also done deeper integration work with a couple of newer vendors. Looker is one of them. Chart.io is another one. And certainly, we'll continue to work across the spectrum doing integrations with partners. But these are ones that we have spent some time with, getting natively integrated into what they support in their UI. Something that those of you who have been using Snowflake, I'm sure, have noticed is that we actually now do have usage monitoring and reporting inside of Snowflake. So when you log in as an administrative user into the Snowflake UI, you have the ability to go to a tab that allows you to see details about what CPUs or what CPU credits your virtual warehouses have consumed and what storage credits you've consumed. And so that gives you that drill down ability to really understand your usage of Snowflake. And then the last thing, which is very important, is that we actually have rolled out a complete support portal. So some of you who've worked with Snowflake before know that email has been our primary mode of support, but we actually have now put a full back-end system. It happens to be based on Zendesk, which I know a lot of you have used in the past. That is available now to all of our customers. And so not only is that a place where you can file support requests and track those support requests, it's also got a lot of great information in the knowledge bases there, information that is shared by Snowflake, and also that we find by working with our customers is interesting and valuable for people. So that's certainly not everything we've done, but to highlight some of the things we've been working on. As we go forward, we always are looking for more feedback. That's really what drives our product roadmap, and so we really appreciate the feedback that we've gotten from all of you in the past, and we look forward to getting more of that in the future. If I were to really summarize, where is Snowflake going forward? There are really three key things. One is that we'll continue to increase our ability to integrate with the data ecosystem in deeper and deeper ways. We'll also focus on allowing greater extensibility and automation of Snowflake, because we've actually got a lot of you using Snowflake really kind of under the covers. You have applications that are driving it, you have scripts that are pushing data in, and so we really want to do additional work to make that easier and easier for you. And that all falls into this bigger category that we have of just making sure that Snowflake is the easiest data warehouse for anyone to use. We've made great strides in eliminating a lot of the overhead and management and tuning that you need to do with a traditional data warehouse or even a big data platform. But there's still more things that we have in mind that we want to do to make it something where you really do just focus on getting your data in and querying it, and not on all of the other aspects that a traditional system would have you focus on. So with that, I know we're basically toward the end of the time we have. We've answered some of the questions as they've been asked going through. Certainly, if you have more questions, feel free to send them in the chat. We'll stay on for a few minutes. And also, obviously, reach out to us at Snowflake if you have any additional questions. There are the emails for the people who are on this webinar. We're all more than happy to take direct emails and answer questions that way. If you're a Snowflake customer, you can certainly contact Snowflake through their support portal or through our support email alias. And if you're interested in any other aspects of Snowflake, by all means, you can contact us through our website, and there's a info@snowflake.net email alias as well. So definitely hope that you've learned from this webinar and saw some new things you hadn't seen before, and look forward to hearing your feedback going forward. And thank you, everyone, for attending.